You can demonstrate the action of an ancient Noria by taking a foam pie plate, some of these little portion cups that are made out of styrene, and some duct tape and a dowel, and I have a couple of little tubes here that make the bearings for the dowel. And you can demonstrate it easily by just simply stapling those little cups to the plate, and you can see that every rotation the cups dump water. Well, other than being a pretty crude model, what can we do with it, and how can we apply some understanding of basic science and physics, and then where can we go from there for design optimization? Well, the first thing we can do is we can figure out, based upon how much these cups hold, how much they actually will transmit. And so we can actually pour out each cup and then pour it into a graduate cylinder and determine that for each cup dump we have about 10 milliliters of water. So in this model, if we use this model and went at a certain rate, we could determine the rate of flow for how much water we could deliver. And by scaling it up, a student could design this and draw a diagram of this in a much larger fashion and upgrade these to jars or pails and determine how much can be delivered. So one variable can be how much water is possible with an Noria like this. The other issue is how far can it be delivered, and as you will notice here, the water can only go as high as the top of the cup, and so the difference between the water level and the cup level can tell you how far you can actually move the water horizontally or vertically. If we have a higher wheel, that can be scaled up then, and we can determine that. The last thing that you can calculate is, if you take a Newton scale, you can actually do some work and force experiments. In this case, if I load up my Noria and make sure it's got plenty of water in it, and I calculate the force required to pull on my shaft, it looks to me that I have almost half of a Newton in force. Now, if we want to get into how gears, wheels, and so forth also are an advantage mechanically, I can go further up on the shaft. Now I'm up to about 0.25 newtons here in terms of force required. So I can calculate things like rate of speed and amount of water delivered, the rate at which this shaft can rotate, and also the forces required depending upon where and who is going to rotate this wheel, whether it's you or an oxen. And so we can also look at the forces required and the distance. So if I'm way out here, yeah, the force is not too much, but I have to move it over a longer distance. So there are a variety of applications of the simple machine that can be applied to the Noria.